I was just praying with my eyes closed that this was going to work.
Things, if they're going to go wrong, do go wrong. This thing could fail, you know.
If it doesn't work, it's over. Lights off.
Exploring the solar system is not for the faint of heart. It requires courage, determination, and ingenuity.
This is like the first Renaissance voyage over the oceans, but it's to another planet.
Can we send a spacecraft through that environment?
There's no question whatsoever that this is one of the most difficult technological jobs that the human species has ever tried.
It's a very violent, dangerous, deadly place.
Through failure and triumph, the people who risked it all for human exploration are providing new insights.
Holy gosh.
I was stunned.
We found the Holy Grail.
It's definitely the most interesting place in the solar system.
Wouldn't that be cool if Pluto has or had life?
We're thinking, holy crap, Batman.
These are the missions that change how we see the solar system and ourselves.
We are the only generation that will ever explore the solar system for the first time.
As I take man's last step from the surface for some time to come, but we believe not too long into the future, I believe America's challenge of today has forged man's destiny of tomorrow.
This prediction was more accurate than Eugene Cernan could have known in 1972. "50 years later, for the first time in human history, we now have images and stunning detail of the major planets, many moons, asteroids, and comets taken from space by man-made machines. These images bear witness to the tireless work of the people who went in search of answers to humanity's biggest questions."
Humanity, I think, has a general quest for knowledge. We tend to just ask questions and wonder why. The nature is to look up and to look around you and to want to understand your surroundings. And so the first thing anyone looked up and wondered about was the sun.
The sun at the center of the solar system is an incredibly hot object. This hot, raging ball of gas. In order to be able to truly see the sun, the interior, the surface, the atmosphere, we have to go into space.
Status check.
Go Delta.
Go PSP. First stage systems. Propulsion. Go. Hydraulics. Go. Box. Go.
This mission has been a long time coming. You know, that for 60 years we tried to do this mission.
We're going to go to the most extreme environment in our entire solar system. We're going to go in and we're going to touch the sun.
8, 7, 6, 5, 4, 3, 2, 1, 0. Liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe, a daring mission to shed light on the mysteries of our closest star, the sun.
The sun is a constant in our lives. It rises every morning, it sets every night. And yet when you look at the sun, you will see that it is anything but constant. It is a continually changing, incredibly active star.
The story of the sun is very much the story of the solar system. Finding out how it works is still a work in progress.
That hazy atmosphere that you see during a total solar eclipse, the sun's corona, is hotter than the surface of the sun. And that really doesn't make sense. It breaks the laws of physics.
And we don't know why. If it's that hot, why does the gas stay on the sun? hot materials move really fast. And if the gas molecules are traveling faster than escape velocity, there should be a wind streaming away from the sun.
And this radical idea was predicted by an American astronomer, Eugene Parker.
In 1958, space was thought to be a hard vacuum. And while the light and heat from the sun could pass through space, the enormous gravity of the sun would prevent any matter, such as gas, from reaching us. But Parker thought differently.
The idea was contradicted by several observations.
He went through the mathematics, he went through the physics, and he predicted the hot atmosphere of the sun has a high pressure, so the gas is wanting to push outwards. And there's a really important consequence of that. The gas streams out into the solar system. The sun is literally expanding into space.
I realized that we had the supersonic expansion of the outer atmosphere of the sun.
Publication of Parker's radical idea was repeatedly rejected. But finally, he convinced the Astrophysical Journal to accept it.
But still, it's ridiculed.
Just because the paper was published had no positive effect. They were not behind it because they just believed it was wrong.
3, 2, 1, 0.
Four years after I made the proposal, there was a spacecraft going to Venus.
And they did indeed discover that the sun does have this outflow of gas coming from it. The solar wind does exist.
The rest is history.
This discovery was momentous. All of a sudden, space is no longer a void. It's no longer a vacuum. It's filled with material. It's filled with this wind from the sun. And it has some real significant effects on our planet.
8.
In 2018, NASA launched a spacecraft called the Parker Solar Probe.
2, 1. Liftoff of the mighty Delta IV Heavy rocket.
It's the only spacecraft ever to bear the name of a living scientist.
Wow. Go, baby, go.
The sky lights up and you realize that it's never coming back.
The Parker Solar Probe would reveal the sun to be as dynamic as Eugene's research predicted. The strange, powerful phenomena Parker observed when it touched the sun characterized the celestial body as incomprehensibly hot and enormously variable. So it followed that Mercury, the planet closest to our star, would be a blistering world of extremes. But even here, explorers would find something that few expected.
When I became the head of planetary science, Messenger had launched, and it was on its way to Mercury.
Messenger was all about exploring the full surface that we'd never seen before, but also we had to really think about how we develop our technology to survive this environment.
The Messenger spacecraft was designed to travel millions of miles and survive a temperature range of over 1,100 degrees Fahrenheit. And it went into orbit around Mercury 7 years after launch.
What Messenger did was it provided, as its top science priority, a high-resolution image of the entire surface of Mercury. But the mystery was that there were bright spots. There were small, bright spots. And then one of the Messenger scientists took all of the bright spots and laid them down on the map of Mercury. Every single bright spot was inside of a crater that is permanently shadowed.
We have found what we believe is ice, water ice at Mercury. It's in one of the hottest regions in our solar system. So how did the ice get in there?
No one expected Mercury to contain water ice. And water indicates one exciting possibility to planetary scientists: the possibility of life.
When you're talking about where life is and where the kind of chemistry and ultimately biology that might produce something like us could take place, at the moment it's looking like it might be broader than just one little planet at the Goldilocks distance.
Extraterrestrial life is the holy grail of space exploration. What it could reveal about the universe, Earth, and humanity itself is a powerful incentive. But knowledge isn't the only motivator for human activity in space.
We can't deny that we rode to the moon and to the other planets on the wings of war.
Our solar system holds the answers to some of humanity's greatest questions. But historically, it's been world politics rather than pure curiosity that drives innovation in space. The Cold War led to some particularly radical science.
The Soviet Union, they understood the huge propaganda value of victories in space. The best way to prove superiority would be to get to Venus first.
We should not forget that every launch is also perfecting essentially military technologies.
Space exploration has a dark side. We can't deny that we rode to the moon and to the other planets on the wings of war. The reason we have these rockets that can launch payloads into orbit and beyond is because they were developed to destroy cities.
The Cold War made space exploration a matter of national pride for the US and the Soviet Union, a dynamic that ultimately led to numerous groundbreaking missions, including Venera 9. This huge, complex Russian spacecraft was built to send back the first image from the surface of another planet. The race to Venus was on.
On 20th of October of 1975, this joint stack of spacecraft of lander and an orbiter approached Venus and separated from each other. The orbiter approached Venus and started a braking maneuver with its engines to slow down its speed just enough that the gravity field of Venus would capture it.
This component of the Venera 9 spacecraft had become the first man-made object to enter orbit around Venus. But the mission was far from over. The lander began the long process of touching down on the far side of the planet.
The lander was a ball-shaped capsule covered with a special ablative surface. And once it entered the atmosphere of Venus and started braking, layer by layer burning the ablative surface and at the same time slowing down tremendously from its initial entry speed.
The heat shield and a sequence of 3 parachutes slowed the lander from 820 feet per second to 160 feet per second. During this descent, the lander's top was ejected and data collection began.
There was an antenna, a transmission antenna exposed, and that allowed it immediately start transmitting data to the orbiter, which in turn relayed back to the ground control.
The first parachute sequence ended when the third detached.
And it pulls out 3-canopy main parachute system. which allows the lander really slow and gentle descent.
The lander would then spend 20 minutes methodically taking measurements of the atmosphere. But its brutal voyage was not over yet.
When the probe is around 50 kilometers over the surface, the command is sent to cut the main lines of the parachute.
The atmosphere gets hotter and hotter and more dense, to the point where it's 100 times as dense as the atmosphere on Earth. And that means that you're falling through, it's not quite a liquid, but it's a gas that is approaching the properties of a liquid, and that would slow your fall. And then when you get to the surface, it's almost like going through the ocean.
Venera 9 wasn't the first lander to get to the surface of Venus. But it was the first to send back pictures. This was the first image ever taken by humans on the surface of another planet.
That was a real triumph of exploration.
This remarkable scientific accomplishment was just the beginning. Spacecraft have now sent back images of numerous other planets, asteroids, and comets. But few have had the emotional impact as our journey to Mars.
These rovers were not inanimate objects to us. We were part of them and they were part of us.
In 2004, 2 rovers, Spirit and Opportunity, landed on the red planet in search of one thing: sedimentary rock.
When geologists go out in the field here on Earth, and they want to look for layers of sediment that have accumulated over time. This is literally the historical pages of the book of the Earth. At this level was where the dinosaurs were, and at this level they died, and at this level new life became. You can just read that book of history.
Scientists chose Martian landing sites based on their likelihood of containing sedimentary rock. Spirit landed in an ancient drainage channel off of Gusev Crater. But all it found was a vast scorched lava field.
We were crestfallen that none of our predictions about what materials would be there were that we were wrong. The Opportunity was completely different.
Opportunity really hit the bullseye because it landed in a place called Eagle Crater, in which Mother Nature has done you a big favor. At some point, she slammed a meteorite into the surface of the planet, excavating this big hole, and basically gave you this archaeological dig, if you will.
These were sedimentary rocks that would have been formed by liquid water. And it was a classic sedimentary sequence that we've seen on the Earth in many places.
And this is where it really gets interesting.
We see these little bead-like things in the soil. We thought, what could these be? I mean, people started conjecturing. But when we put the infrared eyes on them, we can see iron and oxygen in them. We're thinking, holy crap, Batman. We found hematite.
Hematite is a mineral here on Earth that's formed in water, and a lot of it, in moving water, that allows this mineral to be formed. And they were all over the place.
Holy gosh. We found the Holy Grail.
The rovers were expected to last 90 days, but Opportunity's hematite discovery was just the beginning.
They outdid their warranty by factors of hundreds.
were several years into the mission that we had real trouble with Spirit. Spirit had lost one drive wheel. In doing so, we got stuck in a sandy crater, and that was the end of Spirit, yeah.
But opportunity just shines like a radiant star, because this rover keeps going and going and going. Then in 2012, a new rover drops into the party. Curiosity, equipped with a drill and carrying an entire laboratory on its back. This machine rolled into town and immediately changed our view of the red planet.
As we dug into the soils, and we found, to our delight, it had carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. That's everything between these two fingers. All the right stuff that life is made of is on Mars.
Opportunity roamed Mars for 15 years, exploring more distance than any other rover in history. But its journey came to an end in 2018 when a severe dust storm struck.
It's this unstoppable machine. It just keeps driving. And then in June of 2018, here's a dust storm in the distance. It turns out to be a whopper.
The sun was almost blacked out. And at that point, there was no power getting to the panels, and we tried for months and months and months until there was just nothing. And at that point, you eventually, you say that's the end, yeah.
We had one final day where they called the team out to JPL, the Jet Propulsion Laboratory, where anybody that wanted to come and be there when they sent the final commands could come. We had all gathered in this area called the dark room overlooking mission operations, and we're watching the flight commanders sending off the last commands to the rover. We did basically 4 final pings. The light time delay comes and goes. We got no signal, and everybody just kind of sits there in silence. And then the manager of the mission, John Callis.
This concludes operations for MER-1, spacecraft ID 253.
Says, thank you for your 15 years of service.
Thank you.
But this is the end, so, this is MER signing off the net.
MER project off the net.
In the dark room, it was just silent, and everybody's kind of looking around, and we're like, this is it. This is actually the end.
Opportunity's mission was over, but its dogged pursuit of knowledge lives on as scientists strive to learn more about our mysterious universe. And where better to look for answers than comets? Leftovers from the formation of the solar system, comets contain the building blocks of our world.
To learn more, you want to go and rendezvous with a comet. You want to fly alongside it. And of course, then the idea comes up, you would want to touch down on the surface. You want to land there, sample material.
To do all of that in one mission is incredibly gutsy.
10, 9, 8, 7.
The first time I heard about the mission, I thought they must be joking.
6, 5. Décollage.
We launched in March 2004. The whole travel to the comet was an adventure for Rosetta.
So we did this thing to use the planets and to use their gravity to slingshot us through space on a different trajectory with more speed in order to be able to get to the comet.
After this, we came back to Earth. This one gave us the last big kick. We were really launched very fast, but getting very far from the sun. We could not keep all the systems on board active because the illumination of our solar panels was getting very weak.
So the decision was made, in fact, to turn it off.
I hated that concept from the very beginning. I've been fighting it for years. I was convinced we would never do it. It was too crazy. Switching off the radio signal is like cutting a vital link.
You've been flying a spacecraft for 7 years. It's at hundreds of millions of kilometers away. And what do? You send a command to switch it off and wake it up 3 years later. It just doesn't make sense. And this is what we did.
We spent 2.5 years without contact. And we waited.
We couldn't talk to it while it was in hibernation. We needed it to wake up, which it was due to do on the 20th of January, 2014.
3,
2, 1. We were sitting all in the control room, waiting for the signal to come. And this was probably the most tense moment of the mission. This was everything or nothing. It was life or death.
Why is not coming?
Everybody was getting very nervous.
It was very difficult to bear. We started really getting worried.
Then suddenly, the signal came.
When the signal came, it was a big relief for me personally. There was an explosion of joy.
A little blip on a noise spectrum told us Rosetta was there and it was calling home. But now the mission starts because now we have to get to the comet, fly around the comet, orbit the comet, and land on the comet, all within the next 10 months.
The Rosetta team had successfully woken a dormant spacecraft millions of miles away. But the real challenge was just beginning. After 2.5 years of radio silence, Rosetta had come back online right on schedule. A decade after launch, the spacecraft was about to touch a comet for the first time in history.
The comet we ended up deciding to go to with 67P Churyumov-Gerasimenko.
At the beginning, the comet was just a very small dot. And then day by day, the comet was growing in the field of view of the camera. You have this spacecraft visiting an ambassador from the solar system from 4.5 billion years ago. It's modern technology visiting an ancient relic. It's really profoundly emotional.
We saw this incredible shape. Some people have described it as a rubber duck.
It was amazing. It was beautiful. Scientists were just stunned with their mouths open. Comet 67P is about 4 kilometers in size. If you were standing on the bottom of the comet, you might see a flat, dusty plain. If you were standing on the head of the comet, it might look more rocky. If you were standing on the neck of the comet, you would be in this interesting valley, kilometer-high cliffs on either side. There's so many different types of surfaces and variety. You could spend the rest of your life exploring every little part of the comet, not see the same type of thing twice.
The images the Rosetta mission returned are as visually stunning as they are informative, and scientists still analyze them today for anything they can reveal about comets and their place in our universe. But of course, some of the most exciting data space science can provide isn't visual at all. In 1995, spacecraft Galileo arrived at Jupiter and began recording data that suggests conditions almost beyond imagination.
The Galileo spacecraft carried along with it a probe, and it's sort of like this size, and it had a big heat shield to protect it around it.
There were no cameras on board, only sensors designed to withstand an extremely violent introduction to Jupiter.
And so in July 1995, we launched that probe and sent it in the direction of Jupiter. Now, it didn't have engines, so we weren't guiding it and saying, go there. We just sort of sent it on a trajectory towards Jupiter. It was coming in at something like 130,000 miles an hour. So it was pulled in by the gravity of Jupiter, and we had to slow it down. And so this heat shield heated up to about 3 times the temperature of the surface of the sun. And then eventually we kicked off that heat shield, put out some parachutes. And so as it went down, we were able to get a sense of what it was like. What we were expecting was 3 separate layers of clouds. And we went down. It's like, where are the clouds? Where are the clouds? We're not seeing the clouds. What's going on?
Ironically, after 5 months in space and years of mission planning, it would take a ground-based telescope to reveal Jupiter's secrets. When Galileo reached Jupiter, the probe showed no evidence of the clouds scientists expected to find, and the team was baffled. But infrared data taken from ground telescopes revealed the problem. The probe had landed in a particularly dry, hot location.
So I think we realized that our whole idea of exploring these planets with single probes is a little bit susceptible to going into the wrong place.
By the time the probe had got down to about 160 kilometers, something like 23 times atmospheric pressure, it was now starting to get really hot. And so at that point, the electronics is just not working anymore, and it stops communicating. But let's imagine what it would be like if you could be in a pressurized capsule as you get deeper down. It would get a little calmer, a little less turbulent. The pressure would get higher and higher.
It's so hot, everything's vaporous. Eventually I get down to material that are almost like rock clouds, and they're probably precipitating.
Now, when you get down something like 10% of the radius, you're now getting to the point where the pressures are about 1 million times Earth atmospheric pressure. And the density is getting really high. And at that point, hydrogen changes its phase. It's no longer molecules, protons and electrons connected together, but the protons and the electrons are moving separately, and it becomes metallic. That is, it becomes electrically conducting. I suspect it would look like mercury. A glob of mercury is what it would probably look like.
If you existed, you would be, unbelievably thin, flat-out pancake.
You get to the center of Jupiter, we're talking 4 times the temperature of the surface of the sun, 50 million atmospheres pressure, and a density that's denser than the heaviest metals that we have on Earth.
And counting, this is Titan Launch Control.
Without any doubt, the most risky element of any space mission is the launch.
T-minus 15 seconds.
When you put 8 years of your life into designing and building and testing something which is going to go into space,
9, 8,
and then seeing it on the top of a rocket as being vibrated and accelerated on its way to Saturn, it is quite a feeling.
1.
When it did go off, it created a huge amount of light, and then the rocket went behind a cloud.
And then the nose cone came out, and you went, whew.
Exploring a planet such as Saturn is a very risky business. The mission, called Cassini-Huygens, was one of the most technically demanding ever undertaken.
When Cassini was approaching Saturn for the first time, our experiment was systematically scanning back and forth the planet Saturn. And we were amazed to discover that the system was filled with molecules of oxygen. And we mapped this out, and we noticed that the peak in the distribution was just a distance 4 times Saturn's radius from the center of the system. We knew that the moon Enceladus was orbiting just at that distance.
Enceladus is a tiny moon just over 300 miles in diameter.
Enceladus originally was on the itinerary, but only marginally so. It was another very interesting Saturn moon. Small, very shiny, very white, very bright. But other than that, too small to be interesting.
It was in the first close flyby that the magnetometer team detected something interesting that they didn't expect.
It looks like it has an atmosphere. Well, anybody that knows anything about moons says that's too tiny. It can't have an atmosphere. It's way too small to hold onto anything.
If you flew by the South Pole, it looked like there was an atmosphere, but if you flew by at the equator, you didn't see anything at all.
Yet Enceladus had another surprise in store, and what Cassini found would open up a whole host of new possibilities. When the Cassini spacecraft showed evidence of an atmosphere at Saturn's moon Enceladus, the team was shocked. And what they found next permanently altered the existing conceptions of Jupiter's tiny moon.
And we went back again and again, and all of a sudden realized that not only it had an atmosphere, it was an icy atmosphere, but it had these plumes coming out of the southern pole.
And here's water geysers, on a tiny moon.
And that water that was coming out of what we've later found out to be an interior ocean, not only did it contain water vapor, but it had traces of ammonia, methane, H2, CO2, and then there was a whole host of organic compounds that we could also see.
And now we can put all that information together to get a picture of the shape of the eruption and also the material that's being erupted from inside of Enceladus. And amazingly enough, that material has the basic building blocks of life. This says to me that would be a good place to go and see if there's any form of life there.
It is increasingly evident that life might exist in even the unlikeliest of places. And where less likely to find life than the dwarf planet lingering at the edge of our solar system, an average of 3.7 billion miles from the sun, Pluto.
As we were flying up to Pluto and imaging it day after day and week after week on approach, we could see this bright feature on the surface. One morning, we got an image back, and as soon as it came up on the big screen, I remember a NASA official who said, "Do you see that? Looks like a heart." And as we got closer and closer, amazingly, it looked more and more like a heart. I think that's what emblazoned Pluto into the public mind as this amazing place at the frontier of our solar system.
Pluto's heart measures about 1,000 miles across and is composed of nitrogen ice.
We believe that structure might be supported by water underneath the surface. There could be an ocean underneath Pluto's surface.
There probably is some kind of liquid water ocean. It's very deep down inside, but we think there's a pretty good chance that it's there.
This is one of those things where if you find water, is there a chance for life? Wouldn't that be cool if Pluto is actually one of those places in the solar system that has or had life? That's just mind-blowing right there.
The exploration of our solar system is far from over, but it has already taught us what a rich, varied, and strange place it is. But scientists will agree, the greatest discoveries are yet to come.